Welcome to my channel, Easy Learning. Thales Theorem. Today I am going to explain you the proof of this theorem, that is Thales Theorem, or it's also called Basic Proportionality Theorem. Now, Basic Proportionality Theorem is related with a right angle triangle. This is called Thales Theorem because it was put forth by the mathematician called Thales. So this is to honor him. In his name, this theorem has been proposed. So it's also now presently it is also called as basic proportionality theorem. Now, first let us see what is the statement of this theorem. It states that if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. This theorem is applicable only if a line is parallel to one side of the triangle, whose proof we shall see by both activity method and also analytical method. So first let us begin with the activity method. Now proof of the basic proportionality theorem for an acute angle triangle by activity method. Now here you see ABC is a triangle and DE is parallel to BC. Now, what this theorem states that if a line is parallel to one side of a triangle, that means in this case, DE is parallel to BC, then this line DE divides the other two sides in the same ratio. So, I have drawn this DE parallel to BC and let us measure the length of AD. Now, if you see the length of AD, if you read from the scale, it is 2 centimeters. And if you see the length of DB, it is 1.8 centimeters. So that means AD upon DB is 2 upon 1.1, which is 1.8. The ratio happens to be 1.8. Now let's measure the other side, that is DE and EC. You see DE, it's again 2 centimeters and EC is 1.1. So AE upon EC is 2 upon 1.1, which is 1.8. So from both this, you see, we are getting 1.8, 1.8. That means AD upon DB is equal to AE upon EC. This is possible only if DE is parallel to BC. Now let us take the other ratio, one more ratio of the same triangle. Now let us take the length of the parallel lines and one of the sides. Now I am planning to take AB and DE and BC. Now if you see the measurement of AB, AD is 2 centimeter, DB is 1.3 centimeter. And if you see that 2 upon 1.3 is 1.54. So AD upon DE is 1.54. Now let us measure the length of DE and BC. DE is 1.3 and BC is 2. So AB upon BC is 1.55. So AD upon DB is equal to AE upon EC, which is 1.5. Therefore, the ratio why I have taken these two sides is, it is not only the two sides, you can take the third side which is parallel also, even then the theorem holds good. So when I will teach you the analytical method, I will show you the other forms of the same ratios so that you can know that when we are solving a problem, we can use this theorem for different ratios and different sides so that you get a clear idea. Now let us take another triangle, that is, now I am taking a right angle triangle. Now in this right angle triangle, I have drawn ST parallel to QR of triangle PQR. Now ST is parallel to QR. That means now you find the ratio of PS and SQ. If you see PS is 1.5 centimeter and SQ is 0.5 centimeter. So 1.5 upon 0.5 is 3 centimeters. That means PS upon SQ is 3 centimeter. Now let us take the other side, that is the hypotenuse of this right triangle. That is PT upon TR. PT is 2.4 centimeter, TR is 0.8 centimeter. So this happens to be 3 centimeters. So if you see here, Both the cases we are getting 3. That means we can conclude that PS upon SQ is equal to PT upon TR, which is equal to 3 centimeter. Now, similarly, let's take the parallel lines. Now, here PQ, PS upon SQ, and this is STQR. So, when you're taking this triangle, here we need to take the ratio PS upon ST. PS is 1.5 centimeter here, and ST is 1.8 centimeter. So PS upon ST is 1.5 upon 1.8, which is equal to 0.8. Now let us take the complete triangle, that is PQ and QR. PQ is 2 centimeter and QR is 2.5 centimeter. So 2 upon 2.5 is 0.8. Here again we are getting the same ratio. That is PQ upon QR is 0.8. And here PS upon ST is also 0.8. That means these two ratios are equal. PS upon ST is equal to PQ upon QR. So we say that if a line is drawn parallel to one side of a triangle, it divides the other sides in the same ratio. So this is how we prove the basic proportionality theorem using an activity method. Now, before we go into the analytical method of the proof of this theorem, we need to understand a few concepts. That is, the concept you should be aware of to understand the proof of the basic proportionality theorem. Now, let us take a triangle ABC. Now, once you take a triangle ABC, it has got 3 altitudes. So, from here, if you draw, you can draw AD as a perpendicular to side BC. CF is a perpendicular to side AB and BE is perpendicular to side AC. So now if you want to find the area of this triangle, now area of triangle CAB is equal to half into base into height. So half into base. Base is AB and height is CF. So area of triangle CAB is half into AB into CF. Now let us slightly flip this triangle and bring BC to the base. When I bring BC to the base, then AD becomes the height. Now area of triangle ABC is half into BC into AD. Again let me flip the triangle now and bring CA to the base. Now BE becomes the height and area of the triangle is half into AC into BD. Now if you see all this triangle, it is one and the same triangle, only we have been changing the base and the height. So triangles being the same, only the base and the height is different. So the area of all the 3 triangles will be equal. That means area of triangle CAB is equal to area of triangle ABC is equal to angle BCA. So that means for a particular triangle, though you change the base and the height, the area doesn't change. Why? Because area is nothing but the region occupied by the closed figure. So area happens to be same even if you change the base and height of a triangle. Another concept which you need to know is, concept you should know is, suppose you take a obtuse angle triangle. That means obtuse angle triangle is one of the angle is more than 90 degrees. Then this is called as an obtuse angle triangle. Now for this particular triangle, if you want to find the height from the vertex of the triangle, you have to drop a perpendicular to the base and that is the height. So this will be the height. So if you see this height, in this obtuse angle triangle, the height of the triangle will be outside the triangle. Height is not inside the triangle, it is outside the triangle. That's why I have indicated with the blue dotted line. So the triangle's height is outside. Okay. So for an obtuse angle triangle, height of the triangle is outside the triangle. Now let us consider one more case. See, M and N are 2 parallel lines. Okay, and I take 2 points P and Q. And P and Q, I take a point R, join R to P and R to Q. Okay. Then I also take a point S, join P and Q to S. Take a point T, join P and Q to T. So here I am having three triangles which are between the two parallels M and N. Now area of this triangle, that is PQR. Area of triangle PQR, I take PQ as a base. If PQ is a base, then height is the distance between the two parallel lines. So distance between two parallel lines at every point is same. So that means area of triangle PQR is half into PQ into H. Now let us take the triangle PQS. When you take PQS, again PQ is the base, and therefore area of triangle PQS is half into PQ into H. Now let us take the third triangle, that is PQT. Here again the base is PQ. So area of triangle is half into PQ into H. So if you see here, the formula for all the three areas is same. That is area of triangle PQR is equal to area of triangle PQS is equal to area of triangle PQT. So the result states that triangles on the same base PQ and between the same parallels, that is M and N, that is M is parallel to L, are equal in area. The triangles on the same base and between the same parallels are always equal in area. So these two concepts which you need to note to understand the proof of the basic proportionality theorem. Now let us see the analytical proof of this theorem. So when you say basic proportionality, the question could be framed in these three different ways. They can ask state and prove Thales theorem, or they can write state and prove basic proportionality theorem, or they may write it as state and prove BPT, or they will write prove that, and they'll write if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. Now, in this last case, the statement of the theorem you should know. Because once you read the statement, you should realize that yes, he is asking you to prove basic proportionality theorem or Thales theorem. So sometimes the state, that's why we need to know the statement very clearly so that you must be able to tell which is the theorem he is asking you. Okay, it could be asked in any of this. So even the statement, you must learn it by heart so that you understand what is it expected from you. Now, before we proceed with the proof, a few important instructions while writing the proof of a theorem. Proof of any theorem must have the following headings. Marks are allotted for each heading. There is a possibility of losing marks if one or more of the heading is missing. Also, if you don't know the proof of the theorem, at least write the heading of the up to the proof. You will get some marks instead of no marks for the question. The headings are statement of the theorem, which is given in the question. You can just write that, draw the figure. You will definitely have an idea how this figure should be. So it's a triangle and a line parallel. So you can definitely draw a line triangle and draw one line parallel to one side. Then what is given? It is given that you are given a triangle ABC and a line DE is parallel to BC. That is what is given. Now what you have to prove? You have to prove that ratio of sides are equal. That is AD upon DB is equal to AE upon AC. And if you need to do some construction, then you have to join certain parts to modify the figure to facilitate the proof of the thing. Okay. So make sure that you are writing at least this, so you will get some marks instead of getting a 0 for the question. Now let us continue with the proof. Now see here, first, as I said, you must write every statement. Statement, if a line is drawn parallel to one side of a triangle, intersecting the other two sides, then it divides the two sides in the same ratio. Now then draw the figure. So this is the figure. Now here, after having drawn, what is given? Given is a triangle ABC is given in which DE is parallel to BC and it intersects AB at D and BC at E. So this much is given. What you have to prove? You have to prove that AD upon DB is equal to AE upon EC. Now, to prove this, we need to slightly do some construction. So the lines which I have shown with red lines, these are the construction parts. The join BE, join CD, join D, draw DE and DG perpendicular to AC and EF perpendicular to AB. So this is the construction portion which I have shown with the red lines so that proof of the theorem could be easy. Now let's continue with the proof. Now, since EF is perpendicular to AB, that is EF is perpendicular to AB. So, therefore, EF is the height of triangle ADE and also area triangle DBE. So since this is perpendicular, it is the height of this triangle and it's also the height of this triangle, which is an obtuse triangle. So if you see that, you try to take the ratio of the two areas, that is area of triangle ADE upon area of triangle DBE. Formula is half into base into height, half into base into height. So for this, it is half into base is AD, height is EF. So half into AD into EF upon, when you take the bottom triangle, base is DB and height is EF. So half into DB into EF. So half cancels, EF cancels, so it's only equal to AD upon DB. Now let us take the triangle which from this side. So that is here DG is the height of triangle ADE and also DEC. So DG is height of both the triangles. So when you take the ratio area of triangle ADE upon area of triangle DEC, you get half into AE into DG upon half into EC into DG, which is equal to AE upon EC. So let this be the second equation. Let's take this as the first equation. Now, you know, triangles, that is DE is parallel to BC. So these two are parallel and this triangle DBE and DCE both are on the same base DE and they are between the same parallels. That means just now what concept we have learned, their areas must be equal. So therefore, triangle DBE and triangle DEC are on the same base DE and between the same parallel DE and BC. Therefore, area of triangle DBE is equal to area of triangle DEC. Let us take the reciprocal of these two. It becomes 1 upon area of triangle DBE is equal to 1 upon area of triangle DEC. Multiply both the sides of this with area of triangle ADE. So if you get that, you get area of triangle ADE upon area of triangle DBE is equal to area of triangle ADE upon area of triangle DEC. Now from the first condition, if you see, this is equal to AD upon DB. So that means area of triangle ADE upon DB is equal to AD upon DB. And from the second condition, you find that this ratio is equal to AE upon EC. So from 1 and 2, you get this condition. That means AD upon DB is equal to AE upon EC. So this was the proof of the basic proportionality theorem. Okay, so it's not just take the ratios of the two triangles and equate them. You get the answer. So the proof of this theorem you must know by heart, and it is a proof which almost every year this proof had been asked. So the proof you have to learn it by heart. So practice it. It will be very easy and you will get full marks for this. Now let's see the other forms of the ratio, that is corollary which we call other forms of the BPT ratio. What was the ratio? AD upon DB is equal to AE upon EC. That is the original BPT ratio. Let us take the reciprocal of that. You can also write it as DB upon AD is equal to EC upon AE. This could be the ratio, second form of the same ratio. Add 1 on both sides to the original ratio. Add 1 on both sides to the original ratio. So AD upon DB plus 1 is equal to AE upon EC plus 1. Let's take the LCM. It becomes AD plus DB upon DB to AE plus EC upon EC. Now, if you look at the figure, AD plus DB, AD plus DB is the complete side is AB. So AD upon DB has become AB upon DB, and AE plus EC, AE plus EC is equal to AC. So it is AC upon EC. So AB upon DB is equal to AC upon EC. So BPT can also be written in this form also. This is the third form of the same ratio. Let us take the reciprocal of this third form. You get dB upon AB is equal to EC upon AC. This is your third form. Now let us consider the parallel lines. When you take the upper triangle, that is ADE, that means AD upon DE must be equal to the full triangle, that is AB upon BC. So AD upon DE is equal to AB upon BC is the fifth ratio. You can take the reciprocal, you'll get DE upon AD is equal to BC upon AB. This becomes a sixth ratio. Take the other side of the triangle, it becomes AE upon DE is equal to AC upon BC. Okay, AE upon DE is equal to AC upon BC, the seventh ratio. Take its reciprocal, you get this. So there are totally 8 ratios. The above ratios are used to solve problems when they give a particular side and ask you to find some of the third side. Then these ratios, so depending upon what is given, you have to select the ratio and find it. So let us put them all together in niche. So BPT is applicable only if DE is parallel to BC in a triangle ABC. If this condition is satisfied, then this all 8 ratios come into play. Else, you cannot apply basic proportionality theorem. So this is applicable. So parallel conditions are must to use these ratios. Yeah. So this you must remember these ratios because this helps you in solving problems. And this is just putting the values and simplifying. You get this usually they'll give for 2 to 3 marks. So you can ensure that along with BPT, they will always give one problem related to BPT. So make sure that you know all these ratios clearly. Now, so we have learned BPT, the proof of the theorem. I think you must have understood by now. Now let us see what is the converse of the Thales theorem. Here, when you talk converse, here the result of the basic proportionality theorem is used to prove that DE is parallel to one side of the triangle. In what we did while proving the basic proportionality theorem, we had taken DE parallel to one side and we proved the ratios equal. In the converse, we will take the ratios as given and prove that it is parallel. Okay, so what should be the statement? That is the statement of the converse of Thales or basic proportionality theorem is, if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third line. Now what is given? Given a triangle is given ABC and a line is M intersecting AB at D and AC at E. Intersecting AB at D and AC at E, and the ratio is given that AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. Okay, this is given. Now what we have to prove? We have to prove that DE is parallel to BC. That will be the converse of this. So now let us see. First, now how to prove this? We use a assumption. Suppose that DE is not parallel to BC. If DE is not parallel to BC, then there must be some other line which is parallel. So let us take DF parallel to BC. So if DF is parallel to DE is not parallel, but DF is parallel. If DF is parallel, then by basic proportionality theorem, AD upon DB must be equal to AF upon FC. So AD upon DB must be equal to AF upon FC. Let us be the first condition. But what is given in the question? AD upon DB is equal to AE upon EC. And this is what is given. If you see these two equations, 1 and 2, the left side is same. So from that we can conclude that the right side should also be same. So from 1 and 2 we get that AF upon FC is equal to AE upon EC. So these two sides are doing. Let us add 1 on both sides. When you add 1 on both sides, it becomes AF plus FC upon FC is equal to AE plus EC upon EC. Now again you see what is that AF plus FC? AF plus FC is the full length AC. So you get AC upon FC. And AE plus EC. AE plus EC. Again it is the full length AC. So AC upon EC. So AC upon FC is equal to AC upon EC. And these two ratios are equal. That means FC is equal to EC. FC and EC are both equal it is. And how can they be equal? This is possible only if F and E coincide. So that is DF is the line M itself. But DF is parallel to BC. Hence we can conclude that M is parallel to BC. That is DE is parallel to BC. So this was the proof of the converse of basic proportionality theorem. So you need to use this concept when they ask you to prove that the line DE is parallel to BC. When they ask you to prove these two are parallel, then you need to use the converse concept. First, you need to prove that the ratios are equal. So because the ratios are equal, we can conclude that the DE is parallel to BC. So that is for solving that we will take in a next video to solve problems based on basic proportionality theorem. So before I close, let me tell you what I am. My name is Vijay Kumar Raju and I'm a mathematics teacher. I am teaching and preparing the students for the class 10th for the board examination for the past 8 years. If you like my method of explanation, and you want to be trained for your 10th class board exam, you can WhatsApp me at the number given with your name, place, school name. I usually charge rupees 30,000 for the entire course of 10 months. If you book now, I offer it for 20,000 for the entire course. Sooner you start, better your result. This is my number. It's a WhatsApp number. You can WhatsApp me on this number and I'll get in contact with you. So I think you like the thing. Now, before leaving, please do subscribe for this channel and also click the like button and the bell so that you will get all the updates which are coming related to the subject. Thank you for watching and stay tuned.